All right, so this is exciting. This is our first lesson. So this corresponds in your textbook to 1A and to AP Classroom Topics 1.1 and 1.2. Okay, so this is going to be a lot of definitions, and so I will highlight the definitions that are the most important. So what is statistics? What is stats? And basically this is just the study of data. And what does this word study mean? And I think that's the important thing here. So what happens in this whole year, what we're going to do with this word study is we're going to collect data. We're going to analyze that data. We're going to display the data. So that'll be in a graph or a chart or a table. And then we're going to justify. And this is where we would draw conclusions on something. And then finally, we're going to do some inference. And inference is when we take data and then we infer or we apply that to a larger subset. Okay, so this is our stats problem solving process. That's this right here. So what are we going to do? The first thing that we're going to do is we're going to formulate a question. And you can think of this a lot like what you have always studied since elementary school with the scientific process. So we're going to formulate a question, which could be your hypothesis. We're going to collect data, we're going to analyze the data, and we're going to interpret results. Okay? And so the first thing that we have to do here is determine what an investigative question is. And so investigative question is new this year to AP Stats. So this is a new thing that's going to be tested on the test. And what we want to do is we want to look at what a good statistical investigative question is based on. So the first thing that it has to always include is it has to include the variables being measured. And so being measured, or we can say being evaluated. Because sometimes we're not actually going to measure something. Sometimes we're just going to look at data. So evaluated. All right. So the second thing that your question has to have is that we have to make sure that the data can vary. Now, here's why this is important. This means no yes or no questions, or, oh, I'm losing my pen here, not a number. So, for example, if I asked you, how many hours did you study last night? That's going to be just an hour. Now, if I asked you, how many hours did you study every night over the past week? Well, that data is going to vary. So it's not a single number, but it's something that's going to vary over time. Okay? All right, next part of this that we have to have is that we have to have a conclusion in context. And you're going to hear this in context all year, and it's really important. So let me give you an example of what that in context looks like. So when we did the Parkinson's activity, this would be a good experimental question. So can Joy Milne correctly identify Parkinson's disease status by smell for more than 50% of all shirts like the ones in this experiment? So let's talk about this. So the variables being measured. So what's being measured? What's being measured are the shirts, right? Is the data going to vary? It did vary because we had yes on some and no on another. So we can have yes, no, but we have to have multiple yes, no's. It's not going to be a single yes, no answer. And then the conclusion in context. So the conclusion is for more than 50%, that's our conclusion. And in context says that this is the Parkinson's disease experiment. So this is a great question, and it's different than if I just said, did Joy identify Parkinson's by smelling? That would be a single yes or no question. All right. So a bad one, how much screen time did you have yesterday? Again, it's just a single number. All right, so let's look at an example. All right, so here's what this says. In 1970 and 80, Quick and Pepsi ran a marketing campaign targeting one another to gain a larger share of the U.S. cola market. It was called the Cola Wars. To determine if the majority of U.S. cola drinkers preferred Pepsi over Coke, Pepsi set up a blind test in stores and public locations across the country. 2 identical cups were placed on the table, one with Coke, one with Pepsi. The taste testers were not told which drink was which. After trying both drinks, the tester was asked to identify which drink they preferred. So here's the whole experiment that they ran. So what we want to do is we want to figure out what is the investigative question. So the first thing that we have to do is we have to look at what is being measured. So what is being measured is right here. Pepsi and Coke. These are the 2 things. These are the 2 variables that are being measured. Okay, so the next thing here is I have to look at being measured how. So can my data vary? Well, my data is going to vary because they're going to pick whether or not they determine which drink they prefer. So identify which drink they prefer. This means that my data is going to vary. And then the other thing here is we want to look and see, okay, in our conclusion, what do we want to know? We want to know which one they preferred. So this is my conclusion right here. This tells me that my data is varying. And then when I talk about in context, when I talk about when this is in context, the majority of U.S. cola drinkers, okay, are tested in stores and public locations across the country. So this across the country tells me that they're like-minded. This is all in context. So if I take these things, simplify this out, and just write a sentence here, what I want to know is during a blind taste test, do the majority of U.S. cola drinkers, this is my context, across the country prefer the taste of Coke or Pepsi? So if you have a paragraph like this, what I would tell you to do is break it down as much as you can and see if you can identify the components, and from that component, then you can go and write your investigative question. All right, let's talk about some definitions. So what we're going to do is we're going to have populations and samples, and this is incredibly important. So a population and a statistical study is the entire group of items or individuals we want to gather information on. So the population is the entire group. Okay. Now, let me show you why this is a little bit challenging. So I have this population. This population can vary. And this is how it varies. I might say that the population is all high school students. Now, all high school students is super broad. So I might say all high school students in Texas. I could say all high school students in Frisco or at LCA. And I can break this down. Every one of these is a population. Okay, so our population is something that can vary based on the context of the problem. Now, if we want to gather data from every individual or every item that we're looking at, we call this a census. And a census collects data from everything in the population. Now, in the U.S., we do a census every 10 years, and that's when the government actually looks at every single household, and from that household, they want to get stats. How many people, what's your income, yada, yada. The reason why we do this every 10 years is because you can imagine how hard it is to go to every house, every apartment, every rural farm in the whole country. So population is the entire group. Now, when we take a sample, this is going to be a subset of whatever our population is. So if we go up here and we're talking about all high school students, we don't know if this is all high school students in the US or all high school students in the world, but we could take a sample, and that sample would be the subset. If our population was all high school students at LCA, then I would take a subset. My sample would be a subset of just the students at LCA. So the context of your problem is super important because you're going to have to identify which of these would be a population. Okay, we talked about this term of what does using context mean. It is whatever the problem is about. And don't skimp on your details on this. So if you look back on the one that we had over here and we say, do the majority of U.S. cola drinkers across the country, I didn't just say, do the majority of cola drinkers prefer, but you've got to actually give context, which means you have to write. And in your case, in most of the time, you're going to be typing, so it'll be even easier. Okay. So why do researchers usually collect data from a sample to get information about a population rather than conducting a census? And we just talked about this. So we said that, a census is every single thing in the population. So if we look at every person, every car, every whatever we're taking our census on, it takes a lot of time and resources. All right, so let's practice this. Let's look at this. So here it says identify the population and the sample in each of these different settings. All right, so I'm going to read this first one, and we'll walk through it, and then I'm going to have you do the second one on your own. So to estimate the average length of time a patient must wait in the emergency room of a hospital during a given week, hospital staff record how many minutes it takes for each of 50 patients to be treated by an ER doctor or nurse from the moment the patient enters the ER. Okay, so first we're going to talk about our population. Now, our population here is going to be all patients treated by an ER nurse or doctor over a week. Now, this over a week part, this is important because if we just say all patients treated by an ER nurse or doctor, well, I mean, that could be 1,000 people or 100,000 people, right? But if we look up here, it says estimate the average time it takes for a patient in the waiting room, so an ER of a hospital during a given week. Okay, so what is my sample? And my sample would be, it tells me right here, we looked at only 50 patients, so 50 patients whose wait times were recorded. So we don't want to just say 50 patients. There are 50 patients who were treated by the ER. And you could say that too, but since we're measuring minutes on this, I would say wait times, but 50 patients who were treated in the ER. Okay, so I'm going to pause this. I want you to go ahead and read part B and then answer that one on your own, and then I'll show you the answer. Okay, here's what we have. So population, all lifeguard shifts scheduled at a local community pool over 2 months. And this doesn't have to be word for word, right? But if you've got the general stuff in there, so all lifeguard shifts scheduled, because that's what we're looking at. We're looking at the scheduling. Where our population at a local community over 2 months. And then the sample was just the 20 different lifeguard shifts selected. Okay, so when we're talking about samples and populations, we're going to use two different numbers that are going to talk about a value. So our sample size, we're going to use a lowercase n, and our population size, we're going to use an uppercase N. So here's what this would be in this case. So for this example B up above, my N here is my sample size, which would be 20 shifts. And my population size right here would be all shifts. So we don't know this number, so right now we would say that this is unknown. Sometimes you'll know this number, sometimes you won't. Sometimes it's going to be like this, all shifts. Now, when we talk about these numbers, so our lowercase n and our uppercase n, we're going to talk about these in terms of a value. So when we're talking about a population, we call that value a parameter. And when we're talking about a sample, we call it a statistic. Now, it's really important that you remember this. Here's a little cheat way. When we're talking about parameter, it goes with the P for population, and when we talk about a statistic, the S goes with sample. So that's just a little cheat way to remember parameter and population. Okay, so highlights the important things that you need to know on this page. What's a population? What's a census? What's a sample? What is a parameter? And what is a statistic? Those are all vocabulary words that should be solid. All right, let's go on to the next page. So now we're going to talk about observational units and variables. And this is not anything new. We're just going to break this down because this is going to determine how we're going to study things in the future. So the first thing that we're going to have here is we're going to define this an observational unit is also called an individual. So an observational unit or an individual is an object described by a set of data or statistical study. Individuals can be people, but they might be animals, they might be whatever. And these are normally the rows in a data set. Now, something that's important. The old term that we used prior to this year was individual. The new term that we're going to use in this new stats class is observational unit. So this is the term that we want to use, but you might see individual often. Okay? And when we talk about the object being described, this is basically what the data is talking about. So what the data is talking about. Might be in a table, it might be lots of different things. Okay, so the observational unit is what the data is talking about. A variable is a characteristic that can take different values. So variables can be split into two types, categorical or quantitative. And those are normally the columns in a data set. So we would have rows of data this way, and then we would have the values of the data in the columns. Okay? Now, we have two types of data that we're going to look at right now. We're going to look at categorical data, and we're going to look at quantitative data. Oh, quantitative. Okay. Now, categorical data talks about or places individuals in specific groups or categories that are labeled. Here's what I want you to think of. I want you to think of qualitative from science class. And quantitative take on a numerical value that makes sense to do an operation. So if I have a bunch of data, can I add it? Can I subtract it? Can I take an average of it? So is it a number, a numerical value? Now, let's break this out in some categorical and quantitative data that we're going to talk about, okay? So categorical, something that could be like gender. Classify, are you a boy or are you a girl? It could be color. Are you wearing a green polo or a black polo? It could be size. Now, let's talk about size for a minute. Because when we think of size, we think about something like small, medium, or large. But it could also be something like a shoe size. So 8.5 or a 9, or you might wear an 11. Now, the reason why this is categorical, and I know you're like, well, wait a minute, those are numbers. If I took your shoe sizes and they were 8.5 and 9 and 11, and I added these up and took an average of these, that wouldn't make sense because you are specifically an 8.5 shoe size or an 11 shoe size. So here's an example where it needs to make sense or it's going to be categorical. All right, so another example of when we can put numbers in this is your grade level. So I could say that you're a freshman or a senior, right? if we look at this in numbers, 9, 10, 11, 12, I wouldn't average these and say that you're a 10.75. You're not. You're either in 10th grade or you're in 11th grade. Okay? Another thing that's categorical that deals with a number is a zip code. If I took everybody's zip code in here, I'm not going to add them up and average them because it's going to change the value. All right? So categorical, if it doesn't have a number, it's usually super easy. Like if I told you you have a city, or I don't know, are you wearing a skirt? Are you wearing khakis today? Okay, now we have quantitative. And remember, quantitative is quantity, so this is a number. And first we're going to have discrete. And our discrete quantitative variables are going to be whole numbers. And so our whole numbers could be things like people. We're not going to have a fraction of a person. It could be something like blood pressure, for example. Blood pressure is something that's going to give you a whole number answer. It could be something that's counted. So if I threw out a bunch of Jolly Ranchers on the table, I would tell you to count those, and hopefully we don't have one that's like half eaten, right? So it would be a whole number. So when we see something that's continuous, this is going to be something that's fractional. So it's going to be something that is a piece of, if you put a number line together, right, I could have a fractional component. So 0, 1, 2, 3. I could have something here that would be 1.5. It makes sense to have a number that's there. So something that you can do with fractional components would be height. Another thing could be time. When we think about time, we can think about 1 hour and 23 minutes, right? We can have a fractional component of time. And then anything that is measured. If we're measuring it, then we don't have to have a whole number, okay? So, like you see up here with categorical, just be careful. Just because it's a number does not necessarily make it quantitative. So think of something else maybe that you have here. So another example could be a phone number, or a survey response. You take a survey on a scale of 1 to 5. That would be something that would be a categorical value. All right. So numerical values where counting makes sense. In other words, decimals would not be appropriate. We showed that up there. That is a discrete quantitative. And numerical values where decimals are appropriate would be continuous. And so when we look at our definitions over here that are the most important, this observational unit, the term variable, categorical, quantitative, and then within quantitative, discrete, and continuous. Those are all the important definitions you need to know. Okay, so true, false. Every variable that takes a numerical value is quantitative. And we know the answer to that already. We just talked about that on the other page, and this would be false, right? So we know that some things can't be averaged to make sense. So, like, for example, maybe your birth month. All right, so here's an example. The table displays information from a sample of 10 randomly selected large airports from around the world. And so here's all the data. So it says, identify the observational units and variables in this set, and then classify each variable as categorical or quantitative. So I'm gonna change this up a little bit. I'm gonna add something on here. So what is our population? Think about that for a minute. Okay, it is large airports from around the world. And then what is my sample? And it tells you right here, 10. So 10 randomly selected airports. So kind of go a little farther. This large airports, all this data here, these are going to be parameters. And these, the data that I get from this is going to be my statistics. Okay. All right, so now let's answer the question. So identify observational units and variables in the set. And so my observational units are right here. They're the 10 randomly selected airports. So this are my observational units. And now I'm going to list all of my variables, and then I'm going to go ahead and list it. So I'm just going to make a list over here, variables. And that's all the stuff that I'm doing here. So this airport name, the airport name is my randomly selected airport. That is my observational unit. So the airport name is not a variable. But I do have elevation. And when I list a variable, I'm going to list a unit if it gives me one. So elevation in feet. And if I look at this right here, these are all whole numbers. So I'm going to say that this is discrete, quantitative. And then I go over here to municipality. And this is all cities. And so this is going to be categorical. Next one here, I go over and I have countries. And again, this is going to be categorical. Next category here is going to be radio frequency. And this is going to be in megahertz. And if we look at this, I see fractional components. So this is going to be continuous, quantitative. All right. Next I have runway length. And this is in feet. And I see that these are all whole number values. So this is going to be another example of discrete. And then the last one, the last variable that I have here is runway surface. So runway surface. And this is concrete or asphalt, which is going to be categorical. Okay. That's it for today.